So we're going to go back to Chapter 2, Section 4 to kind of cover some of the chemistry basics. Again, hoping that some of this refreshes your memory from some of the information in physical science and some of your other classes. But we need some of this foundation for chemical reactions before we can really get in depth when we talk about photosynthesis, cellular respiration, those type of things. Chemical reactions. A chemical reaction is a process that changes or transforms one set or one chemical into another. Chemical reactions can move in both directions, and this is a chemical reaction below. So we're looking at the reaction for the production of water. And in this reaction, you have two hydrogen molecules. So you have a hydrogen bonded to another hydrogen and one oxygen. And this oxygen is bound to another, and it's actually doubly bond. We'll talk, probably learn more about that in chemistry. However, both hydrogen and oxygen are what we consider diatomic elements, so that they are going to be only occur in pairs, and that's why we see them in a pair here. And when we get those together, under certain conditions, we are going to create two water molecules. Again, this arrow sign here is indicating kind of where the reaction is going, but oftentimes you are going to see the reaction arrow in the reverse, letting us know that both of these can occur. We'll kind of talk more about this in regards to photosynthesis, but understanding that chemical reactions can move in both directions, and they do tell us of something that's changing. So you're having hydrogen, oxygen that are being turned into water. So if we go back to our equation from before, we have to understand some of the terminology behind this. Reactant. A reactant are the elements or compounds that enter a chemical reaction. So in here we'd have our hydrogen and our oxygen that we would consider reactants. One way to think of this is the reactants are generally on the left side, while products are going to be on the right side. And these are the elements or compounds that are produced from a chemical reaction. Chemical reactions always involve a changing of the chemical bonds that join the atoms. And we think about this as we had a hydrogen bonded to another hydrogen. You actually had two of those, so we're going to draw another one over here. You're going to add one oxygen, which is double bonded, to another oxygen. So what is going to happen is now you are forming something like this. So what is happening is we are actually breaking these hydrogen bonds and breaking the double bond. Then you are going to form hydrogen to oxygen bonds. So because there's a changing of chemical bonds, there's also some energy involved in there. All right. Well, this is another slide. We're not going to talk much about it, but it just reiterates the fact that reaction can go in both directions. So you have the one side here where you have carbon dioxide. I apologize, I don't know why those didn't show up with the subscripts. But you should end up getting this, which if we look at the reverse reaction, this is just the above reaction in reverse. So when you breathe in, carbonic acid is formed, and when you breathe out, it's going to produce carbon dioxide. So breathe in, we get this. Breathe out, we get that. But now let's talk a little bit more about the energy involved with the breaking of the bonds in this chemical reactions. Chemical reactions that release energy are often going to occur spontaneously. And that means when we look at the arrow sign and some of that stuff is, how does this reaction take place? So we can write hundreds upon thousands and upwards of different chemical reactions, but do they always happen? Do they sometimes never happen? And one way that we can look at that is just the energy involved. So if they're going to release some energy, they're going to occur spontaneously, generally. Chemical reactions that are going to absorb energy will not occur unless you have some type of energy. This energy needed to start a reaction is called the activation energy. So there's energy involved with here, whether it's required to break those bonds, or it is released when those bonds are broken. So this involvement of energy leads us into two types of chemical reactions: endothermic reactions and exothermic. And again, when we think the exo part, endo is going to go in, we need that energy. It's going to take in that energy and it's going to store it, generally storing it in some type of bonds. So this is the case for photosynthesis. So it's going to go through this reaction involved in photosynthesis, and that reaction is going to store the energy in the form of glucose. An exothermic reaction is going to release energy. So energy is going to be exit. And examples of this would be cellular respiration. And this releases ATP that is going to be used by the cell. So go ahead. Endothermic is going to take in energy into the equation, into the molecules, the chemicals, that type of thing. And exothermic is actually going to release it from those same things. So if we look at an endothermic reaction, again, if we look at this, if this was the starting point and this was the ending point, the reaction is going to take in energy. It's going to gain more energy than it initially started with. And if we look at this, this piece right here is our activation energy. So the energy required to get this reaction going. So now we have the exothermic, so this is what we're going to look at. And again, this is where it's going to release. There's going to be a release of energy. So our reactants, when we go from the reactants to products, the reactants are going to have more energy per se than the products themselves. And again, so when we're talking about reactions and the rate of that the reaction occurs, some of them can happen almost instantaneously, while others can take very, 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 very long time. So we look to enzymes to kind of speed up the process. So a catalyst is a substance that speeds up the rate of a chemical reaction but is not used up during the reaction itself. Lots of times in industrial processes and other things, there's going to be this introduction of a catalyst that's going to speed up some of these slower reactions. And enzymes are proteins that act as biological biological catalysts. So these are things that are going to help with some of the processes within the body, speed up those reaction rates. And enzymes speed up the chemical reactions that take place in cells. So when we think of our photosynthesis and cellular respiration, there's going to be enzymes involved that are going to help those reactions go faster. So how do enzymes actually work? Well, if we look at our diagram here, we have this enzyme substrate complex. This little kind of piece right here. And what it does is we think of, matter's moving. Atoms are moving. Molecules are always moving. we just talked about in diffusion, because things are always moving around, they have an opportunity to kind of diffuse and also have the opportunity to interact with each other. And we think of the chemical reactions, sometimes we're trying to get these compounds, molecules, etc. to react with each other. So they have to be brought together in order to react. And that's what this substrate, this enzyme substrate substance actually does, is it allows the materials to come together and react. So if you have these guys, they're kind of floating around all over the place. Well, with this enzyme, it gives them a specific place to come together, and when these come in, now they can interact. And then you end up with your brand new product. So when you have that product, you also have kind of an empty or open enzyme substrate complex that can go on then and continue to do the same type of work. So this is how the enzymes work, in the essence that they bring together the reactants so they can interact with one another. So how much does an enzyme affect the reaction rate? Again, we might try and watch some of this enzyme video. I'm not sure if you have access to the link, maybe directly on the PowerPoint. But when we look at the energy involved, so without the enzyme, there's going to be a lot of energy that's required when we think about our activation energy, and I'm just going to call it AE for now. So the amount of energy in order to get this reaction going. When we look at this reaction, this is an exothermic reaction. The products are going to have less than the reactants. So there's going to be this release of energy, but there's an initial energy that's required to get this going. And with the enzyme, they're not as much. Because again, when we're looking at the timing for that, it's going to kind of help speed up the rate of the reaction. So there are a couple of things that we need to be concerned with when using enzymes, and how the body uses enzymes to work as a catalyst and speeding up the reactions. So there can be some things that are going to influence how well the enzyme will work. One is temperature. So at high temperatures, we can actually run into some issues, because very high temperatures are going to denature enzymes. They're going to denature some of the proteins, and because of that, they're not going to be as effective. Lower temperatures also will slow down the rate of the reaction, and that just has to do with the fact that in order for things to react, they need to be able to come in contact with one another. And as atoms and molecules slow down, or they're moving slower at lower temperatures, doesn't give them that opportunity to meet as often as if they were moving at higher temperatures. So there needs to be this type of balance for an enzyme to work as efficiently as it should. pH is the other factor in here. And for different enzymes, they're going to need different pH levels than perhaps another enzyme. So there are certain levels of pH that we are going to look at for specific enzymes. So again, this whole little quick snippet was just kind of a refresher for some of the chemistry behind chemical reactions, just to give us a better base, refresh some of your memories before we start talking about photosynthesis and cellular respiration.